Hello, welcome to today's video. We'll be looking at how we can model our simple residential building from our previous video we've just done, understanding GA in 30 minutes. So if you've not watched that video, please go and watch that video. It's going to educate you more and make you understand a better view of what we are doing today, because in that video we've covered how you can model, how you can position your columns, how you can do your grid, and you can your arrangement of the columns so that it's going to suit well when you're importing into any structural drawing. If you've not watched that video, please go back and watch that video, because that video is going to enable you to understand better of what we are going to do today. My name is STADAS and I'm your instructor. So here we are in the interface. So what you're going to see here now, we're going to see a kind of opening. You can see that the whole interface here is not activated. You can see the color showing kind of a blank apart from opening. You can see where we have the opening. So this is just the startup page. So when you open the product structure, what you're going to see first is going to see a start page. Okay, the start page now consists of open project and new project. So the open project means you can open previous projects, okay, just like every other software that you've known primarily. So new project means you want to execute a new task, okay. So in you executing a new class, the recent project, you can see other projects that have been done, so in this we are looking at new project, all right, since you want to start up a new task. So each time you want to do a new task, you have to go and do what? Click on new project. So you click new project. So you click in new project, you have to wait a bit. You can see the new project and you can see project code. Project code in the sense that you want to put the project title. So you can just type any project title. In this sense, let's just type any project title. Let's just say tooth, okay? Let's say tooth to be our project title, but in a real case, you have to put the main title name of the job. So you can see there are a lot of template. This template comes with a particular code. So in looking at the template, we're looking at various codes in your particular design. So wherever country you are, you feel free, you have your particular code and the annex specified to that, then you feel free to select the particular code that and specification standard that you do. So each of these templates you click here has its own code, specification and standard, all right, embedded in it. So in today's video, we want to using United Kingdom Euro code. If you look at here, if you come here, you can see the Kingdom will have the United Kingdom will have the BS code and we have the Euro code. Okay, so today's video we'll be looking at B the Euro code, because I'm from Nigeria. So in Nigeria we use more of the Euro code and the BS code from the United Kingdom. All right, so if I click on the Euro code here and I'll click on OK. All right, so each that one, if you're using the BS code, you are feel free, you click on the BS code and you click on OK. So when you click on OK, you wait for it to load. So it's going to take you down to the interface. All right, it's going to now open the interface proper, where you're going to see all these items that are blur. They're going to be activated with their proper color. Okay, and it's going to give us a drawing limit over here. So we are still waiting for it to load, so just hold on a bit while it load. Okay, after you might have clicked on OK. All right, so so you can see the drawing interface now. You can see the interface now comprises of different element. You can see here, this is the title bar. Up here we have the title bar. Okay, up here we have the title bar, and you can see over here we have the minimize, the expand, and the exit. So and the title bar we have the logo. This is the logo showing the product structure logo, and we can see the save, the undo and redo, and you can see filter and setting. All right, we'll all come back to this. All right, we'll all come back to this. So if we go to the menu, you can see the menu. We have the building layer, we have the model, we have load, we have a view, analysis, and all of this. So in all of this, it has a particular features, under them, that you are going to use to execute your task, your drawing. You can see the analysis. Analysis contains where you run analysis. We have the build analysis, the flow analysis, and either of this. We'll be taking you step by step in all of this. And you can see the design, where you have the design after you do your check about the design that you have already made. And you can see your report, where you carry out your report, and quantity table, where you quantify the various elements which you've done, and where you can see over here we have our Portal detail. This is where you export your drawing after you might have finished the model and the analysis. You can still, that is where product structure becomes very, very nice and wonderful, because they have the future by which you are going to extract those drawings which you've already designed. okay, to detail them for paperwork, okay, and they have other features here in. So today's video, what we just go back to what the building layout. So on the building layout now, we have the opening drawing, which will not be looking, the opening drawing and the save, and you can see other link files in all of this where you can import your drawing. That is what this building layout is all about. Whereas the building layout construct of the element, like I said, you have the column, the walls, the beam, where you're going to use to do execute your model, like the names imply. That is where you use your modeling to do, and the load is where you look at the particular load and preview how you preview your grid and all of that, and analysis, just like what I said. So let's just go back quick to our. It would have been nice for us to just look at how we can execute a model, right? How we can start to execute our grid lines and all of this. But I don't want to do that simply because, like, to execute your grid line and all that. But I don't want to do that simply because I already have my drawing, which I've already what done from my AutoCAD. Okay, so I'm going to export the drawing which I've already got from my AutoCAD down to the data structure. That's why I will not be using I will not be using the what I will not be using the uh, grid here. So I'm going to import a new grid, fresh grid. So in doing that, we have a lot of various imports. So this want to export external reference drawing. So using external reference drawing, this will enable you to export the file from the AutoCAD down here. All right. So click on what external reference drawing. So if you click on the external reference drawing, you wait a bit for it to load and open. So you can see now this is the external reference drawing. You can see the dialog box has popped up. You can see active, you can see active and all of this. You can see the 3D model, the numbers and all of this. So in this, we've not load the drawing. So what we need to do here is just to add. Okay, what we need to do here is just to add. So just click here to add the particular drawing which you've already saved. And remember the drawing that we've already done. Maybe if you've already done your GA, like I said, if you've not done your GA, if you want to know how to do your GA, please go back and watch one of our video which says understanding GA in 30 minutes. All right, so that will guide you a pathway for you to execute your drawing. So in that video, if you check, we'll save the particular drawing. So after this box will pop up. Once you click on your add, what you need to do is just to scroll to check where you save the file, okay, to check the document where you save the file. So in this, we'll save. If you check on a previous video, what I did here, I save it in what, in the desktop. So if I go to desktop, I save it with what, sample tutor. All right, so if I click on sample tutor, I will just click on open. No other thing, just click on the drawing and you click on open. As simple as that. With clicking that, you're going to see it's going to activate this your plan. So that is that. We don't need to do this, so we have to, I just need just one drawing. If you want to keep multiple drawing, you can keep multiple drawings. So in this, if I click on this file, I'll click remove. So I just export only one. Okay, so that is just it, you know. So we just click the drawing. So we have already get the drawing, so you click on activate. All right, so that's just it. So when you have activated the drawing now, you can see that this is what happened. You can see what we have here, that the drawing has activated itself here. All right, so if you unclick activate, it's going to take it off. So you don't just click and expect it to, you're going to click active, okay, for it to activate the drawing, the floor plan here. All right, so you can see what we have here. If you look what we have here, we have the unit. We have the unit, which is the unit which we use in setting the drawing. We have the color, if you want the color where you have in the AutoCAD to be transparent here. Then the opacity is the degree of transparency from the drawing. So when you increase it, this is how it's going to look. When you reduce it, you can see it's active. You can see when you, I think the software, the system is a little bit issue hanging because I've opened it for a long time. So please bear that. You can see when you reduce it, you can see it is a bit faint. When you increase it, it will be growing up shadows. And it's going to take a little time because of how my system has been working all day. But it's not supposed to be so. When you launch it, you're supposed to be what? Activating as fast as possible. So that is how it's supposed to be working as frequent as possible. And the scale factor 1:1, so just leave it. So the next thing we need to do here is just to do what? To import. So click on import. So I'm going to import the grid and the columns, right? We are importing the grid and the columns, so you can see the grid and the columns. That is why it's very important for you to do what? For you to It's very important for you to save to layer, because if you do not save it by layer, you can see if you don't save it by layer, there's no way it's going to pick it as layer. So if you want your grid has to be saved by layer. If you want a column, it has to be set by layer. If you want to slab your beam, all of them has to be set by what layer, so that the software, the product structure is going to recognize such layer. You don't just pick maybe line 0 and use it to do your grid and your columns and everything. The system is not going to, there's no way the system is going to pick 0 to differentiate 0 for layers, 0 for column, 0 for beam and all of that. All right, so it has to be by layer. So after doing that, you just go to what? You click on import, because everything has to be by layer. So system has already snapped that. So you can look at what we have in the import over here. You can see that this is still active. So by the time this will be done loading, this place now will be deactivated. There's no way this will be open. Just watch what is happening, okay? So you can see that it's still loading. So just wait for it to load and it should finish loading. So at this point now you can see that the software is done loading. It has loaded all the code, numbers of columns and numbers of grid, and you can see the import here. And it's telling you to print. We're not going to print because we've not got up to that point. So right now we're just going to click close, and when we click close, you can see everything has already been what? Activated. All right, it's already been activated. But me myself, I don't want the particular color which I import from AutoCAD. I don't want that color to be here. I just want a blur background such that I already know what I'm doing. So I just need a blur background which I will be able to trace. Okay, trace my columns. So I don't have a lot of colors, because the columns will become with colors, the slab and all of that. The beams will become with colors. So I don't want a lot of colors, jump out. I just want a simple structure. So we just go and click OK. All right. So I click on OK. Click on OK. All right. So clicking on OK now, you can see what we have now. You can see we have the full plan, just like what we've done the G. You can see everything now has already what? Import itself down here. All right. So you can see the grid, annotations and the column. So what you're going to do now, you're going to check the column, because most times when you import, you can see different dimension. You can see here we have, instead of 225 by 225, we're having 226 by 225. Okay, in most cases you can see 224 by 225. So these are little adjustments you just need to make on your own and check the eccentricity. You are still the same boundary, just about 1 milli difference. Okay, so you just need to check all the columns which you set, and just need to reconfirm them if they are the way you want, okay, before you start your design. And the same thing to the grid. So this grid now, you can see we have A2, A3, A4, A5 and all of this. I don't want it to be this way. I'm going to rename this in numbers, right? I can name this side to be 1, 2, 3, 4, 5, 6, and in this other direction, the horizontal direction, the horizontal grid should be what? A, B, C, D, and E, F, as the case may be. All right, so it will be very, very easy for easy tracing, and I want you to always do that. It should be in a number, and in a number and in a alphabetical representation, instead of having A1, A2, because this will be very, very confusing on the side. Trust me, right? So what we need to do here, so for me to do that, let me just go straight to the column. So for me to do this, I can come over here and change the column properties by double clicking or clicking on the column. You right click on one column, you right click, and you can see, you go to property and you click on property. So you wait for it to load. So you can see the properties here, properties of this column. Okay, all the properties regarding this column, you can see them over here. So you can change it here, all right, to make it what? 5. So 2 to 5, 2 to 5 by 2 to 5. Okay, everything intact. Then you click on update. So you click on update and you wait. It's going to load, and you're going to see over here it's going to change. Okay, 25 by 225, you can see the change over there. So what? We'll click on close. So if you don't want to do this, there's another way you can do it very, very fast, which you can just go on the column table. You click on the column and you right click. When you right click, you click on column table. You just click on column table, you wait a bit. You can see it's going to give us a total summary of the column table. So the total summary of the column table, we'll just change it at once, and it's going to just going to change for all of them, right? So this is what you just click on this instead of me clicking on them, changing them one after the other, just the same thing. We just need to click on this particular row, you know, click on this particular row B1, then you go to what column otherwise. You can see column otherwise. You click on column otherwise, so it's going to bring out table. So this is where we'll now change it. We can now say 225 and we'll say okay. So it's going to change all of them in sequence to be what 225, all of them. All right. So we'll do the same thing to here. We have B1 and we'll have B2. So we'll do the same thing to B2. We'll click column otherwise and we'll click 225 and we'll say okay. As you see, it's going to change automatically, and so that's how it's going to change automatically. So the next thing we need to do here is just to click OK. All right, so we'll click OK. So we'll click OK. If you look at the drawing, all of them is going to be 225 by 225 because we've already do the changes, and you can see that everything is just great and how it's ought to be. So as simple as that. So the same thing, we're going to change the grid. So before we change the grid, let's just go onto plan. But for as simple as that, for you to change the grid, this is what you need to do. Just double click on it, so it's going to show you the property. So when it shows you the property, we're just going to change the label. Okay, so you can see the grid property, so we'll change the label. So we'll change this label to 1. Okay, and we'll update. Once we update, it's going to change. You can see it's going to change from A2 to 1, and we'll click close. So that's how we'll do the same thing to all of them. Okay, that's how we'll do the same thing to all of them. So you can see here we're done with the vertical grid. So we just click on the just repeating the same process, all right? You just double click on it, you wait for it to load. When you wait for it to load, just change the label. Okay, so in this direction we want to say A, so click A, we'll click update, so it's going to change it to a single A. Just the same thing I did. We just have to repeat the same process. You double click or you click and you go to properties, so you're going to show you the properties of the grid. Okay, get the property of the grid, you click B, you type B on the beam label, right? On the grid label, because we are changing only the grid label. So that's just what we need to do. And then you click on close. So you can see now we've done with the numbering. We have 1, 2, 3 to 7, and we'll have A, B, C, D, because this is now very, very easy. You can see we omit I because I and 1 is almost the same alphabet, right? So we don't use that when we do a section. Okay, so it's very, very easy for you when you want to denote this column. This column is going to be what? Grid what? A1. All right, be easy for you to do. And this is what? A2, and this is what? A5, and this is A6. It will be very, very difficult, easy for you to identify this particular column or this particular beam when you're using your grid, rather than having a A plus A this. That's why we need to do this changing. Okay, so after this we just go straight to what? Model, because we want to insert our beam. That's the next part, right? You're doing your importation, you're bringing your column and your grid. So now the next step is what? Bringing your beam. So when you're going to insert your beam, you click on model. When you click on model, we have to come back to beam. Okay, we'll click on beam. Now we have two types of beam over here. We have the normal beam and the wall couple beams in between the walls. So we're looking at how we're going to put a normal solid wall between the slab. Okay, so we'll choose normal beam. So if you choose normal beam, you wait for the property to load. So in this, you're now going to look what will be the size of the beam. So in my own case, I'm looking at kind of a 2 to 5 wall. Okay, so that I want to use it to marry the block. Okay, what I have with the column space, I want to have the column size to fit in the block, so I don't have the column extruding out of the wall. Okay, right? So that's the same width of the column what we have. Okay, 2 to 5 by 2 to 5 column, and having a 2 to 5 beam. All right, with a different depth. I'm going to look at the primary depth of 450. Okay, of them with 450 instead of using 500. Okay, and I'm going to look at the eccentricity. The eccentricity adjustment should be what? Middle, because I'm going to look at it. The eccentricity now depend on where the grid lies. Okay, in this situation you can see that the grid is in to in. All right, sorry, is at the center. Centricity in this case is at the center. Okay, but there are some other cases where I guess the centricity is by the side. You can see I don't think I have something of that nature. Okay, so let's just move on. But there's some rare cases there where you have your grid be at the side of the wall, not just being at the center. Okay, so in that regard, let's just start inserting our our beam. So you click on the first one and you move to the last, and you click on the last, okay, and you wait for it to load. I think I'm having a lot of slow issue because I've disturbed the system. Just bear with me. I'm having a lot of slow movement here. So we'll take to the second one, the next one. So that's how we just need to go round and round. So by just simple, if you want to take it out, you press escape. It's going to take it up, and if you press on escape twice, it's going to take off the properties. So what you just need to do is just to press it once, so that you can take it down to the next one. So mind you, once you click on the first one and you click on the last extension, it's now going to do what? It's going to cut the beam into the various parts, just like what you see. It's going to cut it into various parts. You can see. So if you click over here, the same thing what we're going to get. So just take note. So over here we don't have a beam, so we're going to stop it at this point. Either way, and here we're going to take it down to this column. When we're inserting the next one, we're going to take it down to this column. So we're going to have a beam over here. All right. So we are going to press escape. I'm going to press another beam. We're going to have another beam down this spot. It's trying to load. We're going to see another one over this spot. Okay, the beam is going to be at the wall. I don't want the beam to be outside the wall. Okay, I want the beams to be at the same spot where we're having the walls. Okay, so here I'm having another beam here. Straight in here. You can see here that's why we have a column to beam connection. Okay, this is a column to beam connections. Okay, and this is a column to column connection when you're connecting the beam. Okay, so the same thing over here. I'll take this down to this spot. I want to put a beam over here and a beam crossing the span. Then I will lock it up with this beam over where we'll have the staircase. So I'm going to lock it here for the sake of this wall. Okay, I don't just want to end this beam to make this whole area open. Okay, so here now we're going to get a beam over this area. We're supposed to have a column here. So we're going to insert a particular column there. We're going to insert a column, and over here too, because this beam is going to be quite long, so we're going to have a column over there. So we're having a beam here. So, and here too we have over here. Okay, so that's by the way. So we're going to insert another beam here. We have a beam over this area, so we're going to insert a beam here. So there's another beam. That's why we introduce this grid. Don't forget, each place when you're doing your GA, for every area where you need to introduce your beam, you are going to have your grid line there. You can see, because the beam, the structure, this program is going to see the grid line. Okay, for it to insert the beam, it's going to see a grid line for it to insert the columns. That's how this is programmed. All right. So about this area, we need to insert the column over here so that we're going to stop this wall, because this wall is not continuing and I don't want to continue. It's very, very easy for you to throw a beam. A beam can be allowed over there, but I don't want to do that. I just want to keep it simple, especially just exactly the way it is on the architectural drawing. Just want to keep it that same way. Okay. So you can see what we just need to do here, get the same properties of this, and we'll click over here. So introduce a column. I want to introduce a new column over here at that spot, so that I can create my beam. I can stop my beam at this direction, and I will navigate the beam towards this area. Okay, I can have a beam at an L shape. I don't want the beam over here, but that's not how it is in the architectural plan. Okay, that's why I just want to keep it different. All right, so that's by the way. So you can see over here we have the differences. So I want to keep this beam straight. I don't want to really consider this wall. Okay, but if you want to consider, in your own case, if you want to consider this wall, then you can shift it for it to have a very good bonding. But in my own case, I just want to keep it straight with this, so that it to be uniform and straight. Okay, Okay, right. So in that, we now have to go back to what, to GA, to get the beam. I want to bring back the beam properties. Okay, so you can see the beam property loading. So the beam property over here, we have a beam from here down to this spot. So we have that ready. And I'll have another one here. Okay, so just waiting for it to load. So you can see now, I don't want to insert a beam here because I want to consider this to be a partition wall, right? Just want to be a partition wall because these are separation walls between the toilet and maybe the kitchen. You just want to create separations between the particular rooms, the kitchen, between the toilet, or maybe domestic areas, So that's what we use partition walls to do. So in this regard too, I'll be considering this as a partition wall because I don't want to put a column here, because if I check, the whole of this panel can be able to what, to carry my slab for me to be able to what, uh, avoid the beam. Alright, because I'm trying to look at doing a particular design and also looking at saving a cost wise, So you can see what we have here. So from our GA, what we did is just to get a partition to make sure we don't have anything below, anything above what, we don't have anything above 6 meters apart. Okay, because if you look at this one, the beam length, you can see the beam length. What we're having 4650 as a beam length, and you can see the beam width to be 225 and the beam depth to be height. So that's what we're just trying to, to keep it safe. So now we're done with this beam. So what we just need to do now, just to go back to our plan, we just need to go back to the slab to generate the slab. So when you have the load combination case now, you have the load combination case from what we have from the beginning, we have various templates by which we use, okay? You have the hero code which you choose. So each of the templates you're working with, if you're working with each of them, either you're working with the VS code or you're working with the hero code, you just have to look at those load cases when you're loading your slab, because you're loading the slab on top of the beam, and we have the beam and we have the columns, okay? Just like you understand how load is being transmitted. It's going to transmit from the column down, from the slab down to the what, to the beam, and from the beam down to the column. So in all that, so we're going to look at the load cases which we are going to use to do our model. So this is where we are going to do what, to look at all those load cases, okay? Because if you look at, okay, let's just go straight. You look at the loading generator. If you click on loading generator now, you're going to look at all the prerequisites necessary for you to do that. So if you look at now, we have all programs, because the program has already been loaded for to take care of certain diaphragms regarding what you've already choose, regarding the template, the codes of option on the specification they've already nominated here. Okay, so if we look at here now, we look at the vertical and look at what, the horizontal. So if you look at the vertical part, you can see the dead case and the live load, and you can see now if you look at the load case now, we're looking at for the dead load, we're looking at the dead load for 1.2, 1.25, and for the live load we're looking at 1.5 as a factor of safety, multiplying the dead load that we've already input and we are going to generate from the structure. Okay, so and either load cases, if you're looking at your roof life load, your temperature, if you're looking at snow, depending on where you're designing from, and the rain, if you're considering that, so you just have to tick that so that when you're analyzing the software, it's going to take that into consideration. Okay, so in this case, we're not looking at all of this. Okay, just want to keep it as simple as that. So we'll go to horizontal. So in the horizontal, we're looking at how the horizontal load. Don't mind you, these are the vertical load coming down. So we have the rain as a vertical load, we have the snow to be a vertical load, we'll have the roof to be a vertical load. Maybe in this case we consider the roof. Okay, on the load of all these, because we are designing a roof load, because there will be a roof in the building. Okay, so in all of this, a timer, this is when you're looking at the heat. That is if you are designing for a high-rise building, so there will be a lot of high sun. Depending on the sun area, look at in Africa we have a lot of high rate of sun, but there's some other country that you might not really look at it. But in this condition, we'll be looking at the roof and we'll be looking at this thermal of it called for the heat and the temperature conditions of that particular building. And this has to tell us in the concrete, because we're looking at the steel, looking at the concrete border structure. So we need those temperature for it to figure it out, okay? So when you're looking at this, then in the horizontal, we're talking about the horizontal movement, which talk about if you're designing the earthquake, seismic. Now, all the seismic at the foundation, this seismic is mean the earthquake, the vibration along the side. So we're not looking at we're not looking at that in this area, okay? So we're not adding it, okay? Because it's not activated. If we're designing for that, we're going to go to setting and I'm going to set it for the software for you to be able to show them. We're going to apply it, then it's going to be affected in the slab. But for now, we're not considering that. So if you look at the nominal load, you're just looking at when you're factoring the different stages of load, when you're doing normal combination of your load, maybe your torsion, your torsion out to your life load and all of that, considering the shrinkage and all of that. That's to be in that. Even looking at the crank, looking at the crank when you're doing your bar, when you're cranking your rear bars and all that, it's a result of the soil, the concrete and the steel bar colliding together and all of this in the code and specification. You can see what we have our the code here we're looking at. So if we're looking at the wind load, so are we looking at the wind load too? Because wind load is an horizontal load horizontal to the slab. Are you considering that on the slab too? Okay, so in that part, if you're considering it, if you click it, then it's going to what takes this and you're going to add to the consider that in the analysis. But in this situation, since we are trying to make it simple, you just have to leave it. Or by the way, we can still just do what, just click it, so that we just take this and add to the structure. Okay, in as much as we're not doing the seismic, have to be if there is a high level of wind. But furthermore, if there's a high level of wind, there's a way we're going to analyze more of the load. Okay, but in this, let's just take it so that it's going to take that into consideration when running the analysis. Although it's going to make the analysis a bit bulky, but it's good to be safe. It's always good to be safe. So now we're looking at the soil now. The soil pressure, when we're looking at the soil pressure, we're looking at a very, very simple issues here. So in the soil pressure, when we're going to do our soil design, we'll be looking at that. So for now, we'll just look at leave the soil pressure and all of this, all we'll tick and we'll just say okay. So once it's okay, we're going to say the table is going to be what displayed out here. So we're going to wait for it to have a table out here, so you can see all the table regarding the load and all the cases for what we've already identified, what we've already choose has already been displayed here. So you can look at various load cases, if possible, the load cases that was used to do this calculation. Okay, we can look at the G, we can look at this and the P1. So these are the load cases that were used to check, to do the design, to look at all this, to present this table. Okay, so you click on OK and you click OK. So once you click this, it's now going to what take us down to the slab property. So in the slab property, now we'll now look at what will be the height of our slab, what will now be the level of our slab. Do we want to step some or do we want to keep it at the same plane? So if you want to keep it at the same plane, the reduced level have to be 0. So you have the label, which you understand. We have various types of slab. Now various types of this slab now. If you look at it very carefully, you can see we have various icons here telling us how we want this to be done. Okay, you can see this at one direction. If you're looking at a one-way slab, now we have the two-way slab and we have a one-way slab. So identifying that, you can see the first option here. And when we look at the one option, it means when you're designing a slab that has what you have a support at the four corners of it. Okay, and this is when you have 2, 3 support. You just have 2 support, and when you're looking at a one way on it, so this is when you have 2 at the edge, and this is when you have a 2 opposite side, and this is when you have just 1. And with this one, we'll have our cantilever slab. When you're doing a more of cantilever that is fixed at one end, we'll try to use what number 2. So depending on what the kind of slab you're designing, this is what you now do, what you now use to design. So in all of this, we'll be using 1 because we have all beams at all sides. Okay, we'll be using that. So when we want to design the one that have at both sides, and then we can come to look at number 4. We want to design for this. Okay, then we can use that for number 4 to do that design. But for now, we'll just click on number 1. Okay, because that is the option that relates to what we are considering for today. All right. So when we click that, we'll now look at what's the height of your slab. The height of the slab now will be considering 150 thickness, as the case may be, or because I'll be having a lot of piping issues. Okay, because I'll be having a lot of piping in the building. We'll be doing some piping at some area. Okay, at some area of the building. So we can look at designing or let's just leave it simple. this is what we need to do. Since we'll be looking at 150 this area, any area we need we have the toilet, maybe such area now, we can have to see how we want to increase that particular area of slab. But otherwise we can just keep it simple, or we can just let us go with 200. It's not so bad too. We can just run it 200, okay, so that we'll have it to 200 thickness, because of maybe some area will need some pipe and some other area will be different. But in another case scenario, we can look at how we can design differently. Okay, maybe for this area now, let's just design it differently. Then for this other area, we're going to put 150 for where we don't have the slab. Because when you have a toilet and you're going to do your fitting into this, depending on where you're doing your conduit, so it's going to be what you have to look at that. Because sometimes you, as a structural engineer, you don't consider that. But when you go to site, when you send a drawing down to the site, after designing without considering those factors, when you get to site, they will go and tamper with your design. So you have to consider that when you're doing your design, so you know that whether they tamper it or not, you're safe. Right? That's why we're here. We have to be safe. We're not here to just do what you feel is right. We're here to do the right thing, not what we feel is right. So we have to go with what 200 spaces, so that when you're doing it, to be okay with that. So what will be our concrete cover? So look at our concrete cover now, because we're looking at our fire regulations and all that. So let's go with 30, and the label position should be at the middle. You can see it can become shifted to the edge of it, so we don't want that. So I just want to keep it at the center. Okay, that's for the label. Okay, that's for this label that we specified. Okay, and we're looking at the directions. The directions, either a one-way slab and a two-way slab, that's going to go with this. And we'll look at the insertion. Now this insertion have different varieties. You have different varieties of insertion. You can look at by inserting by grid, by beam, by the axis, by point, or as the case may be. So in this simulation, let's look at beam region, because we have beam all over. Okay, so in this area we say what 200. So we can click here 200. Okay, and we have over here it is going to be 200, but here is a bedroom, so we have a toilet here, so we're going to take here 200. So we're going to click here 200, click over here 200, we'll click here 200. So all of that. But if you still want to save cost along this area, we have by which you know that there's nothing here, then you can go with 150. Okay, 150 as the case may be in that area. So to keep it simple, it's not bad if we do so. If we say okay, let's design here to be 150, or we'll keep it the same area. Let's just keep it the same. Okay, let's just make it to be the same along that area. So if you come here now, I want to insert the slab over here. Okay, so at this point now, let me go to number 2, because the free end, this is number 2. So we're doing the same thing at number 2 now. If you look at, I'm going to use pick axis because of this axis. So I'm going to pick this axis, the hidden axis, which is axis K that will hide. I'm going to pick this axis 4. I'm going to pick the next one, J, and I'm going to pick this other axis, which is axis 3. This is it. And I'm going to come back to the first one, which we pick. I'm going to come back to the very first one, which is axis K. So it's going to give us the slab that we'll receive from the staircase. So when you take your first flight, you go to the landing and you fly down to this point before you now navigate to either of this room or either of this other area for the veranda outside there. So that is just primarily okay for this. Alright, so looking at this analysis. So in this regard, I don't know, let me be pleased. So now looking at this other one, so now I want to introduce for this other slab. So what do? We have at one end. So look at the option. Which option defeat what we have here? Option 4, right? So click at option 4. So when we click at option 4, we'll go down to using what? Pick slab. So we'll clean this because we're not using that same effect again, alright? We're not using that same effect again. So we'll be using another new one. We'll pick our new axis, which is this axis. So we want to make sure, okay, this is axis G. This. If we pick this axis, it's not going to cut across this one. So I guess we're going to create another grid for it. So let's escape and create a grid for it. Okay. So you just click this grid and go offset. Go straight down to this point. Okay. Now we're going to click on this grid. And we'll also right click, we'll click on offset. So I click on this. Okay, so that I can be able to get the edge. Right. If I use this grid L, I'm not going to get the edge of this. It's going to give me inside. Okay. So we'll just double click so we can make that grid. Just double click so we can make that grid a ghost, and we'll hide it and we'll say update. So we'll click and we can do what? We'll right click and we'll stretch it out. I want to stretch the grid such that it's going to come over here. You click on it, this again, right click, go to stretch. Go to stretch. Sorry. Go to stretch. Get it at this point. So at this particular grid, let's do the same thing by hiding it. We'll update and we'll hide. So we'll now right click and we'll stretch. I want to stretch it back. I want to stretch it back to where it is. So I'm just making it to be at this point. You can see, just want to stretch it down to this area, so that is we're not going to have a lot of grid colliding to each other, just like what we have. Don't want to have anything colliding each other. Look at what we have here. We are supposed to collide, but because we have to hide it and we have to stretch it out, so that the design will be very simple and straightforward. Because I like my design being simple and straightforward without having a lot of issues. So if I click on this slab, then I can go back and look at, okay, let's go back to 4. Then we'll go back to what? Pick grid. So we'll delete this and we'll go back to what? Click on the first grid here, because we want to get all the grid around this area, because we want to insert the slab this way. So what do? We'll click on the grid available. So click this grid G, and grid 8 that will hide the layer, the other grid L, and we'll have grid 4 and back to grid G. So after that, you can see this is why I created a grid at the end of it, because if I use this grid, if I use grid 7 and grid J to create it, we are going to have this little space taken off. So we will not consider this is going to be. And if you look at the slab flush direct to the wall, not half the grid, okay, not part of the column. So that's why we introduce this grid over here, so you can have the full portions of the slab, okay. So that's why you can see what we have here. So now we're done with the slab. So the next thing we need to do is to generate. But before we generate, what we need to do here, we just have to start making our beam to be in a fixed conditions, okay. So in doing that, we just have to do our hinge, okay. So why do we hinge? We have to hinge so that we have a beam tied to each other, because we want to anchor this beam to 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 each end, okay, to each end of it, to anchor this end, and we also want to anchor this other end, so that the both ends will be in the hinge, because of the moment that will be transparent within the beams, okay. Because if there's a beam acting, let's say we have this simple supported beam and we have a moment acting here, it's going to be having what? We're going to be having a hopping moment up here and a hopping moment along this joint. Then we're going to be having a sag moment, causing here to be in tension and here to be in tension. Although the bottom will be tension, but we just have to consider hinging both ends so that they will be fixed to this other beam. So that's the reason why we just have to what? To hinge the beam. And when doing that, we have to do end condition. Now if you look at a single beam, you're going to see when you click on the beam, by when you want to, you just click on the beam so you can see both ends. It's going to direct you by telling that when you have a single beam in a protar structure, the left end of it is going to be what? It's going to be the what? The I end, and the J is going to be the right side, is going to be the J end. So the same thing to the up. If I click on this other beam, you can see the upper part of the beam is going to be the J, and the lower part is going to be the I. So if I'm considering a situation whereby I want to fix both ends in this beam, although this is a continuous beam, right? So we have to consider this beam to be the I end, then whereas this beam is going, this side is going to be the J end. Because why? I'm going to look at this beam to be a continuous beam, and I'm hinging both ends of the continuous beam. Right? In a situation whereby we have a simple supported beam, we are going to consider it to be simple supported, so we're going to hinge it to be a single beam. So we're going to hinge on both sides of the beam. But when we have a simple supported, a continuous beam in this nature, then what happens? We are going to hinge both ends. We're not going to hinge the internal. We're not going to consider it to be what? Either span. We're going to consider this beam to be a continuous span. We're going to hinge this I end, this J end, and we're going to consider this to be a what? The I end, okay, of that particular beam. So in a situation whereby you have a cantilever, let's say you have a cantilever beam, a beam extending, then such beam is good. You're going to hinge only one part, because in a cantilever beam, you're only considering one part to be in fixed and the other end to be what? Free. Okay. So in this situation, we are not looking at a cantilever beam. When in your other video, that's why it is better for you to keep on following the channel, so you'll be seeing what we'll be doing. But if you're liking what we are doing, please don't forget to give us a thumb up and give us a recommended topics which you want us to treat. Before we continue our hinging, if you have not subscribed to this channel, please, I want you to subscribe. Do that before we continue. And in you subscribing, you're helping us to grow, and it's showing that you're appreciating our effort. That will give us more advantage to keep doing video like this. So let's continue. So for you to do that, you click on this beam and you right click. When you right click on it, you're going to see just like where you see a kind of icon coming out, a dialog box. So what we need to do, and this time we're not going to copy, we're going to locate our update beam end condition. So when we go to beam end condition, we look at now in beam end condition. Now you can see the arrow here. By the time you place your cursor, without clicking, we just see your cursor, just extend your mouse down, you can see no hinge, which means on this particular one you can see that there's no bob at it, which means there's no end at this particular one. So look at both ends hinge. Both ends hinge, you can see the icon here. You can see we have here on both high ends, and you can see here we have on the I, which is this other end, and you can see the J, which is the other part of the other end. Okay, so the same thing, you can see up is the J and the down is the I. So in that, so since this beam, we are looking, this is a simple supported beam, so we're just going to consider what? A both end hinge. So we just click on both end hinge for it to hinge both sides. Then you click on what? You click on apply. So if you click on apply, you wait a bit, you're going to see the hinge. Okay, you can see that it has hinge both end. So this point now is to tell you that what? That this is the hinge. This is just to denote from the software. They use this bubble here to denote that you've already hinged. Whereas this one, don't be confused with this. This one is just to tell you that you've clicked on this beam, that this beam is what? Insert to this grid and this grid. That's to tell you that this particular beam here is tied to this grid and to this grid. That's what is bubble. But this other big one is telling you that you have hinged this beam to this beam. Just like you're having a connection. Just like you're creating a connection. If you are doing a steel, that's what we call connection. Because if you place a steel to other steel without creating a connection, it's not going to connect. So in this situation, we are trying to make it fixed. And I believe you know that. So in doing that now, we don't want to make it pin. We have to make it fixed to that particular joint. Okay. So that is it. And this is a beam to beam connection, right? Like I told you, this is a beam to beam connection. We have a column to beam connection, like what we have here. You can see this. That is this is a beam to column connections, and this is a column to column connection, whereby you're connecting a column to another column. So these are different types of support. Okay, but either of them, they have their consequences and they're all okay. All right. So that's it. Because in days when you're hinging on this beam, it's going to try to make sure that this beam, because this one now is the primary beam and this is the secondary beam, all right, which this other beam is resting on it. So it's going to make sure that this particular beam is going to have a higher slide reinforcement than it has to be if you provide a column here and another column here. It's going to make sure that this beam is going to provide a simple reinforcement. But for you to support it here, so you're having a joint, a load acting on this beam or along this area and another beam area. So it's going to change the diagram of it if it's supposed to be simple. All right. So in the same thing over here, so you can see the force at this end is now going to be, this beam is now going to be supported along this beam. So this is now going to be what, another primary beam, and this will now be a secondary primary, to this particular beam. All right. So this beam is now going to be what, taking care of all the stress coming from this beam as distributed. All right. So in you doing that, so what we're trying to do now, I just have to throw that analysis so that you understand what I'm doing here. But in this condition, we're trying to end both to make sure that both ends are what fixed. So if you click on this beam, you don't need right click because we want to get this end of the beam. So what do? We just go to what, update beam end condition. So what, at this point we want to get this particular eye. So what we do, we click on the eye. So we're going to what, apply to selected beam. We want to apply to the selected beam already. You can see so it's going to hinge this end. So you can see in this condition, because we say eye, it's not going to what, it's going to hinge only the eye direction. It's not going to hinge both and it's not going to hinge this. Okay. So if you've made a mistake and you hinge numerous beam, you can just click on the beam and you hinge one connection. Like in this now, if I hinge this, if I want to hinge this other one now, there's no way I'm going to hinge this and hinge this. If I want to hinge a J, it's going to turn. If I come here and I hinge J, if I come and I hinge on J, if I go back and I click on J, you can see that the hinge is going to leave the I and it's going to transfer down to J. So for you to hinge two beams, you're going to click on both, hinge both end conditions. Okay. So if you click on one, if you hinge only one, it's going to move on that direction to hinge the particular direction in which you want to hinge. If I click on I, which is the preferred one I want to hinge, you can see that it's going to what, hinge for other. So the same thing here, I can come here to hinge on the J. So if I click on the J and I right click and I go to what, update beam conditions. Okay, beam end condition. In this direction, I'm going to click on J. You can see my cursor right there. So I click on what, apply. You can see it's going to update here. All right. So that's by the way. So I'm not going to touch the middle here. Okay. I'm not going to touch the middle here. So I'm just going to do that. So for me to get this simple now, I'm going to locate all the J and I'll treat them as one. So I can just click this angle and I'll press my control key so that I can select all the J instead of me doing them one after the others. Okay. So I'm going to come over here. I'll click on this one. I'm going to come over here because this is a continuous beam. I'm going to click this other beam too. It's a continuous beam. So I want to do all the J at once. Okay, this is a simple beam. You can see. So here now we have this two to be the J end. This is simple supported beam. So that's what we have. And okay, we have another one here. So this is another J end. Okay, this is another J end. So we'll get this end, this other end, this beam, and this beam. So I think that should be all. We've already done this beam, so we're not going to take it. Then another one is here. So we're also going to do this. So when you're doing this, you have to be very careful so that you don't miss track. Okay, you don't miss it. So in that location, we'll just right click. When we right click, we'll go to what, update beam end condition. So we'll look at it, update beam end condition. We'll now go to what, J, because all we are doing is what, for the J end, this other end of it. So we'll just click on it so you can take care of the J end. So the same vein, we're going to do that for the I end, so that we just have to be fast. Okay, we'll click on the beam. So we're going to click all the I end. So we'll come over here, I'll click on this end to come over to this beam, click on this, we'll click on this beam. So it's going to take care of this, and this is going to take care of this side. Right, so this is for this, this is for this. So I'm going to come over here and this is one remaining. All right, so click on this end. Right, so that's that. So we've already done this end, so no need for that. Okay, so okay, I think this is another one that is remaining here. So click on this. So when we click on this beam, the next thing we'll do is just to maybe we'll leave you leave your control and you right click. When you right click, you locate update beam end condition, and in this situation, we have to click on I. So you now say what, click on that. So you can see it has activated. Because this is for this end and this is for this other end without we hinging this other end. Okay, so that's that. So in the same vein, we just have to look at the simple supported beam. Okay, so we'll look at this one, we'll click on this, or we'll press our what, control, the same thing we've done. So we'll just click on all the simple supported beams. Okay, when I mean the simple supported beams, I mean beams that are not continuous, beams that have a single span. Okay, so we'll just click this. Like I said, this video is for the beginners. Okay, I have a lot of guys who have done a lot of gone into the intermediate state. It can still be favorable to you. Okay, so we just have to get all the simple supported beam that has a single span. So if you look at this one, it has a single span. We're going to bring control. I'm going to add it to it. So we're going to create control and we'll just click it. All right, because without you pressing control, it's not going to pick the multiple beam. It's going to pick them single. Okay, it's going to pick them one after the other. But the moment you press your control, then it can pick up some good amount of elements that you want. So after that, we'll just have to what? We'll click on we'll right click. I'll go to update beam end condition. So after beam end condition, what we'll now do is just have to what? We'll click on what? The both end. Okay, because we are dealing on the simple supported beam. So we'll click on both end and we'll apply to the selected beam. So once apply to the selected beam, you can see that it has already, hinged them. So this is very, very essential for we to do. So after this, you can see our column and everything has been done by the model. So the next thing we need to do is to start generating. So we'll start generating. Let's split the view. So in splitting the view, you can see that some of these are turning red. It's because of what we highlight. So let's just escape. If we escape, you can see that it has leave all of them, okay, to the one we selected. So that is by the way. So this is our 3D view, what we've done from our slab. So right now we just want to generate, okay, let's balance it so that we generate. So in this issue now, we can start generating. So we just click on this. You click on what? Building setup. So when you click on building setup, you now go down. You can see we have setting, we have library, and we have a story. So we want to generate multiple our story. So click on uh, story here. So click on story. So it's going to drop down and you have to tell us what story operations. Okay, so you click on the story operations. It's going to tell you what you want to do this. So for you to do this, you have to insert. You can see over here, we have to insert the numbers of story you want to generate. You want to do 4 story, 3 stories, 5 story, as the case may be. So in this condition, since we want to make it very simple for the beginners, we'll just have one story, right? We assume we have the ground floor, have a floor above the ground floor, right? So in this situation, so what do we now do? Okay, or let's just assume we have 2 floors above it, okay, which the column we have is still going to be what sufficient for it. So what we need to do, we just have to what click on insert a story. So insert the numbers of floors which we want to do. So if you want to, this is the first story already that controls the ground and the 00 level. You can see the 00 level over here. It tells you about the foundation when you want to design the foundation. So this is the ground floor and this is the first floor slab. So we have to go on another floor slab. Since we want to go on 2 story, so we have to go on what? We have to go on 3. We have to type 3 over here, alright? 3, which means the last floor is going to be our roof. So for that, we have to insert intermediate floor. What will be, do you want to insert story height? So we have to insert our story height. Let's say our story height should be what? 3 meter 300 millimeter, okay? 3.3. Okay, 3300 millimeter intermediate floor. This is to tell if you want to insert another floor in between floors. So we don't want to do that. So we just have to do what? Click on OK. So if you click on OK, we say yes. So when we say yes, it's going to generate multiple floors. Okay, it's going to give us series of floors. All right. So in this, we have to go back, and when you introduce the series of floors, if you look over here, you can see that we have a thicker blue here telling you that there are elements in this particular story, and there is no element in this other one. Although this story 3 now is activated, but you can see there is no element here, but there's element in this story 1. So we'll go back to story 1 by double clicking on the story 1. So it's going to go down to the story 1, okay? And you can see other stories down here without nothing, and here is a blue, okay? So let's say that we have some element here and nothing over here. So what we need to do, we have to go back to the story. We'll click on the story back, story operations. We'll click on the story operations, and now we have to generate, okay? Because we want to generate, and here you can see, want to look at the selected story if you want to work on that particular selected story. Now this is to insert like we just did. This is to remove if you want to remove a particular floor or a particular story. Okay, let's say you've added and you wanted to add maybe 4 floors and you added 5 floors. So you can come here and click and delete the particular floors you want to remove. Okay, so we can do that. You can also remove that one. Then if you want to delete the story, you can also delete the story completely. All right. So if you want to remove, you have to remove from the top floor. I want to delete, you can delete this one and it can still work. If you want to generate, it means you want to add up what you have already, what we have on the recent floor. You want to take it, you can see the arrow, you want to duplicate it to the next floor. Okay, you want to duplicate what we have from this other floor to the next floor, so we'll make it fast. Then when you want to edit, it means you want to edit a particular story. Okay, so in this condition I want to generate, so we'll generate first. So click on generate. When you click on generate story, you can see what we have. So we have different icon here. So we have what? You can look at the source and you can look at the target. What do we mean? Because you want to generate, okay, you want to duplicate. Where are you duplicating? You're duplicating first floor to second floor. There's another term for it. Okay, want to duplicate the first floor to the second floor. Maybe in some other situation whereby you have what you have on the first floor is different from what you have on the second floor, and what you have on the second floor is the same to what you have on the third floor. All right. So what you need to do, you have to first of all model the first floor, then you generate the second floor. After you click on this, maybe you click on the first floor, then you go to your target. This is your source. You click from this source because you're duplicating this down to the second. And you're looking at what are you duplicating? You're duplicating the columns, the beams, and all this property. You want all these elements that we've done here to be on the second floor. So when you've done that, you just come and you click what? OK. So when you click OK, you look at this dashboard. If it's done, it's going to show you process complete. You can see it has duplicate. Now let's say in a situation whereby what you have on the second floor is now different from what you have on the third floor. So you can now come on the second floor, work on the second floor before you now generate the second floor to the third floor. But in this situation here, we are assuming that what we have in the ground floor is the same all through. So they are symmetrical. So what we have will still generate, okay? This is generate, right? Or in a situation whereby you have what you have on the first floor is the same thing as what you have on the last floor, but the second floor is different. So you can come now, work on the second floor, and you click on this one, and you click on this floor, and it generates differently. So either way, what you want, you can still click. But in this situation, let me just do the same thing, and I click, and I want to generate same, right? I want to generate same. What we have here, I don't want to generate the slab, so I want to take off the slab because I don't want to put on the slab and all this frame. I just want to generate only the beam, so I'm going to take this off because I want to generate only the beam, so I'm going to take off the slab. Okay, so I just want to generate only the beams, the wall, because the walls and the walls and the columns, the walls and columns are the same in this scenario. So we have the columns, the walls, and the beam is what we are generating here. So the grid is constant. The grid is not supposed to be here. The grid is at the same spot. You are not generating the grid, okay? You're only generating the columns and the member because the grid stands for it. Even if you have 100 story, the grid remains the same, okay? So you just click this and you now say what? Okay. So when you say okay, it's going to run and you're going to turn this other place to complete because for each floor you generate, it's going to show you the complete process for each floors, okay? So in this, we'll now say what? Close because we've already generated. You can see what we have here. We can say close. You can see now we've generated them. You can see what we've successfully do there. Because I untick the slab, you can see in the first situation, I generate everything down here. Alright, I generated everything down over here. And in the second one, I have to untick the slab because I don't want to generate the slab. In this situation, I'm having a hip roof. So I'm imagining that I'm going to be having a roof here, not a slab. Okay, so it's not a slab roof. It's a kind of a beam, a hip roof where I'm going to introduce a beam that is going to carry the roof. So that's why I have to take this beam. But in this situation, right here, we are at the third floor, right? So on this third floor, what do? We are going to assume, so on this third floor, we're going to assume we have, if you look at the beam here, you can see we have the same depth of beam. This is 450 and this is the same 450. So I don't want to maintain the same 450 here. So I just want to reduce the depth of this because this depth will have 150 slab, 150 thickness slab, and we'll have what? We have 200 height slab and we'll have 450 depth of beam. So if you look at that, we're having a drop of 150. So in this situation, we're just having a roof. So I want to reduce it to 300 millimeter beam depth. So for me to do that, I can do it one after the other, but in this situation, I just want to do it I just want to do it simultaneously. So I'm going to click on this. I want to click on the beam and right click, just like what we did in the beam process. So you click on the table and you wait for it to load. You can see a box, a table coming out in form of a spreadsheet. So we'll just go to column otherwise and we're going to change it. You can see the table, summary table for the beam is going to come out. So click on the height and we'll go to column otherwise. then you can see column, otherwise this is initial depth of the beam or the height of the beam, whichever serves you better. So we're going to make it 300. So when we click 300, we'll click OK. So it's going to change it at once instead of we changing it one after the other. So it's going to change it at a wrong go, right? So this will be okay. So you can make it 300, you can make it 350, you can make it 375, whatever serves you better, all right? But I just want to keep it simple. That's why I make it 300 millimeter depth, okay? All in millimeter. Be careful with the unit, right? So click close, and you can see there's now a massive difference between this beam and this beam, okay? Because we've shortened depth, the height of this beam to this, so that it can be able to take care of our roof, right? So this is our roof beam. So here now, what we need to do here, right here, is to do what? We forget to add our roof because we're supposed to have a wall load, because we're supposed to have a what? A wall load in this structure. So we'll consider our wall load in this structure. So now we're going to introduce our wall load. So introducing our wall load, we'll just come over here now. We'll click on the internal beam, then you right click. You click on the internal beam, you right click. You also go what? You locate edit load, okay? Because we want to edit various loads. So on this beam now, if you look at where we are now, we are on the what? The third floor. So I want to edit that on the other floor. So let's go to story 1. Always look at the structural tree so that you know the one you're working on, okay? If I didn't look at the structural tree, I wouldn't know that I was clicking the what? I was clicking the last floor beam, okay? So now I look at it and I know that I was at story 3, so I just have to activate story 1, okay? Because that's where we're working on. So activating story 1, so I'll just click on it. I'll click on it, then I'll go to what? Edit wall load. You click on edit wall load, you wait for it to load. It's going to load, showing you various load. We have a point load, we have various types of load. Okay, when you see something like this, you just click continue, all right? So you look at the point load, you look at the vary load, you look at the uniform distributed load, you look at the wall load, okay? So there are different types of load, okay? So if you look at it now, you can see different types of load. Forget about what we have over here. This is the beam. Try to show you the outsketch of the beam. So which kind of load do you want to get on this beam? All right. So this is a point load. This is a point load. This this is a uniform distributed load. Consider the point load telling you to add a particular magnitude of the load. Okay, either in percentage in every aspect of the beam. So you can see the percentage. You can add it in every area of the beam if you want to add your load in percentage, or you can add in distance. Where do you want to locate the point load? Where is the load acting? So if you want to introduce a point load on your beam, if you want to load that, okay, so you can specify that. Then what you insert point. So if you want to do that in percentage, you tell you 50. So if you want to get the distance, you can click on the distance and you can see it's going to change. Then you can insert the distance in which you want to do. So in this situation, I'll be looking at my percentage. Let's just leave it at percentage as it is, because I'm not introducing I'm not introducing a point load and the uniform distributed load the same way. I want to check a different. Let's say we have a particular uh, force acting along the beam. So we're not looking at that. I'm looking at a wall. So we have a partial, we have the trapezoidal load. So we are looking at the wall load because wall is sitting on the beam. Okay, we have a beam along those lines. Okay, so you have to load the beam at the wall. So what do we need to do? You have to come here, activate the wall load. So we activate the wall load now. We have different types of load, but you can stick to the one you have. So I just want to use a manual method to activate it. So what do we do over here? So over here now, what we're going to do now, we're going to have the wall width because we have the wall unit width. So what do we have? We have the wall unit width here. We have 2.4 over here, right? But in this situation, this is when you're looking at kind of the 8-inch block. So now since we're looking at the 9-inch block, okay, what we need to do, we're going to insert here the board 3.75. Okay, because why do I do 3.75? 3.47, sorry, 3.47. So this 3.47 is the total sum of the partition, like the plastering, because the plastering weight, we're assuming the plastering weight to be 0.3 on both sides. So you have 0.3 plus 0.3 at both sides of the wall. So you have 0.6. 0.6, we are now going to add it to the initial weight of the block, because the initial weight of the block is what? 2.47. So what we have initially here was about 8. Look at what we do here. This thing now, they use these 200 bricks to calculate it. So if you have that, that's why they have 2.4 initially. But now we're now changing it to what, to 9 inches block, which is what, 2.87. So we're now adding the partition width, which is 0.3 plus 0.3 at both sides. So if we add it together, so we are doing 2.87 plus 0.3 plus 0.3. So this is how we came about this value here. So we're looking at the wall, because what we have, we're looking at the nominal drop depth. So we have the total beam, the height to be what, 3.3. All right. So if we have 3.3 over here, if we take that 3.3 and if we take 450, if we take 450 out of this 3 meter, 450 out of this 3 meter, what we're going to have is 8,2850. Okay, 2,850. That's what we're going to have. So that is what we're going to add here. Okay, so we're going to add 2,850 over here, 2,850. If we add 2,850 here, you can see it's going to start at the start end and at the finish end. Okay, so that's what we're going to do and the word. So after you might have added all the value that you need, you just click on this. Okay, just click on this guy. You can see now I've not clicked on it, but once I click it, it's going to show the load here. All right, so if I click it, you're going to see it's going to appear a load above. Now with this, you are sure that the load has been appeared. Okay, now we're not considering open what to edit opening. Okay, because this is a middle wall, but in the external wall you can look at the window if you want to introduce that. Okay, but most times I don't like introducing opening, because I want the it to cover for the weight of the glass, because I'm supposed to have a glass on it. Okay, and I'm going to have the window hoods. I'm going to have the window hoods for those scoping for the design. The baluster guys will do that. So most times that's why I love my beams to be open. So I'll just click on this and I'll say what, okay. After this might have been what activated. So it's going to see, it's going to change the color of the beam. You can see from the initial. If I escape on this beam, consider this beam now has a different color from this other one. So what I need to do here, I don't want to repeat the same process again, but if you want to do that, let's say you are assuming you want to create an opening, you can come over here to create opening where you have the windows in the perimeter walls. But in this, let's just keep this simple. So click on this. I will go back to copy. Now I don't want to do it again. I'll just copy copy load that I've already, do what I've already loaded. You can look at the edit wall load now, has something with it. You can see this line cutting across here, cutting across here. Then that everything here has to do with what the load. So you can copy, you can paste, you can delete load, and you can insert word in the drag, whatever, to drag to paste particular. So in this, you're going to copy. The one we copy, you're going to copy that. It's saying what do you want to copy? You want to copy a point load, leave it, just say what, okay. Alright, so when you say okay, it has copied the load. So what we'll do that, we'll copy that beam now is what? Beam 12. One beam 12. So click on the first beam, then we'll press our what? Shift. In this situation, you're pressing shift, not control. Okay. So you want to select all of them. If you press control, you're going to click each of them one by one, right? But if you press shift, you're going to click the first one and the last is going to select it straight up. Then you just what? You do control V, which is what? Your paste. I want to paste them, okay, because I want to paste the wall load. So now I successfully, you can see I've pasted the wall load over here. Everything I'm doing over here is displaying here. We have it display over here. So like I said, you can see how we've done. So we're going to do the same thing. We're going to do the same thing over here. We're going to load one and we're going to do the same thing over here. So we're going to have it. All right. But better, if you want to do it, you can do it on the first floor, then you generate so that everything is going to generate with it simultaneously. Then finally, you can delete the one that is up, just like what we've done here. So the same vein, I'm just going to generate and do the same thing that we've done over here. So right now, we're just going to click on the second floor, and we'll go back to the same vein. So I mustn't click on this. Okay, this is the second floor, so I'll just click any of the beam on the second floor. Okay, this is still the first floor, second floor. Okay, you can see second floor as activate, so we just click on any of the beam. Any of the beam, you right click, you go back to what, to edit beam wall load, right? You click on edit load, go to edit load. The same thing, we'll locate wall load, click on wall load, or click on wall load, we'll go back to the perimeter, we'll do the same thing here. You can see start, you can see the thickness of the wall. Okay, so in this condition now, let's just say the thickness of our wall is what, 225. Okay, so it's 225 what we are considering here. So we'll look at our beam wall load to be the same thing here. What we've already activated is already here. So what do? We'll click on the beam here, and it's going to load here. So by the time you load, you just go up, you click OK. When you click OK, you can see the beam. All right. So doing that, you right click, you go to what, copy. So you've copied this particular beam wall load, and you say what, OK. So when you click OK, the same vein, you click on the first one, you hold your shift, then you can use your mouse to drag this down so that you can locate the end of it. So because we want to get all the beams that are at the second floor, just look at the 3D as we go so that you can see what we are doing here. So by the time you do that, you click this, you go to the last floor. This is the last floor. Then you press Ctrl V, or you right click and you say what, paste. So you paste, and you've seen what we've got here. You can see now this is sweet. Alright, but we've done something wrong here, because if you look at what we have here, this is for this particular one fall exactly with the with the beam. Okay, fall exactly with the side, with the beam height. But if you look at here, we're having a space here because this beam is 300. So in this situation now, we can say we can overlook the process. After overlooking the process, we have to edit. Let me go back to edit this particular beam. Edit beam wall load. So what do I do in the beam wall load? I'm going to edit the height. So it's going to have a different height. Okay, so this height now, we're going to have a different height. So in this height, we're going to take 3 meter. Okay, because the beam is we're taking, because we have 3.3 meters, so we're going to take, the beam is 300, so we're going to take 300 out for it. So the same wall, so the same load, and we'll say what, okay, so that is going to flush under this beam. Okay, it's going to be exactly under this beam without showing. So that's that. So if you look at it now, you can have that. So later we'll edit the whole height. So what do? We have to come here now and check this whole height to know what we've done. So if you click on this, we have to right click and say copy beam wall load. Copy the wall load, and we say okay. Then you go the same process. So click on the beam, just click on the beam here. You can see if you click on the beam, click on the beam wall, then we have to click one, we'll press our shift, we'll locate the last one, or you can press Ctrl V, or you come here and say copy paste, Ctrl V, the same thing, and you paste it, so it's going to show us the same thing. So now, irrespective of this showing up here, we'll just have to go to edit, and let's go back to, after clicking here, let's go to story, operation story, let's go to edit beam wall load. So edit beam wall load here, you can see all load. So story 1 is what, let's change story 1 to 300. So all of them will be the same thing, 300. So all of it is going to size and going to map. Now you have to look at, now these are the wall height. Can you see what we have here? We have the wall height or story info activated. Okay, so you can see story 1, 2, and 3. We have the height specified here, and each of the level, because this level is, they are adding up the level 1, 2, and 3 for all the levels. You can see what we have, and different specification for that, different depth at the walls. And you can see the apply impose load reduction. We don't want to do that because we're not doing intermediate floor along that area. So we can look at the basement grid number. We're not looking into that. Effective wall, we're not looking into that. So we'll look at here now. We have the story, depth. Yeah, so the story, so we're looking at the first floor bottom level. Okay, so we'll leave it at 0. So the depth, we have to look at what will be the depth we're providing for this. You can say, okay, let's provide for a depth of maybe 1.5. Okay, this will say from your natural ground level, what are you doing? From your DPC, right? This is we're talking from your DPC down to the bottom level of the foundation. What are we considering? Let's consider 1.5. All right, so in that, you can now say what? Okay. You say what? Okay for that. So you can now calculate, and everything is going to be as well to extend. So everything is properly fixed. Okay, so that's by the way. Forget the fact that you see this is because of we edited. That's why you're saying it. This thing is 3 meter. Don't be confused about it. All right. So after this, this we are now done with our model. Okay, we are now done with the model because we don't want to make this video that long. So we have to follow us. You have to follow us on the second level, the part two. We're talking about how we can run analysis. So after this, we have to go on how we can run our analysis. So if you've not subscribed, please subscribe and give us a thumb up. Give us a comment on a video you want us to talk about. Please, we do appreciate your effort that you've watched up to this time. Please, thank you and bye for now.